Okay, we got a lot of really good content to talk about today. You're going to
I
want to
see.
pay close attention. Today, we're going to be talking about secondary water sources and using dynamic flow allocation and some tips and tricks for managing different size water sources, different types of water sources, and tying these water sources into different types of mainline configurations. So, as always, you can catch older Tech Talk replays on YouTube. Dan's done a fantastic job building the YouTube channel with these episodes as well as new how-to content, and that you can find that under Baseline Web Training on YouTube. And quick introductions. I'm Andy Humphrey, RSM for the Northeast. We have Dan Conger, National Training Manager, Chris Wright, VP of Sales. And like I said, when we started out, pay close attention. We're going to get pretty technical today, which we hope you appreciate. We know you appreciate. This is why we do what we do. So without further ado, why don't you take it from here, Dan?
Very cool. So today we are talking about sites and configurations that use a secondary water source. So we're all familiar with sites that have one controller and one water source, maybe even just one controller, 1 meter, one controller, one pump. But we're going to start looking at one controller and 2 water sources, or more than 2 water sources, and how you might switch between those. So we've got some examples of some different water sources. I'm going to share my screen, and we already set this up earlier. So
perfect. We nailed it this time. It's about time.
Sweet. So, this most common example that a lot of us are familiar with is just a domestic water meter or a domestic water source. That's very, very common. The other thing that we're going to be seeing is maybe surface water. So surface water could be a canal, a pond, a lake. It kind of depends upon your region, but that's a very common water source. You might be seeing a well. So here, a smaller residential or light commercial well and the pump that goes with it. Your water source could also be a really large pump station. So this pump station is capable of about 1,800 GPM. So by scale, it's a lot larger, but it's still a single water source. Cisterns, this is a rain catchment, but any sort of a tank or a cistern is a water source. Reclaimed are common here in the West where I am. And you had a comment on the pressure gauges there.
Yeah, this picture, I don't know if you've taken this picture or if it was taken within the last year. However, if it were an install happening today, we would go ahead and add pressure transducers, either in lieu of those pressure gauges or in combination, so we can read that pressure, remotely. And for those of you that may be joining us for the first time today or are unfamiliar with some of our technology, we are now able to read the pressure just like those gauges are displaying before and after those valves remotely. So just want to point that out.
It's kind of a bonus feature there. Nice. Here's a sophisticated reclaimed or recycled water. It's essentially 3 water sources in one. So this is a non-medical triple bypass. We've got...
Yeah, and this one, it's just, we should point out, this is absolutely a baseline system. You can see the hydrometers there. This was not a picture that we just grabbed off of Google to show you guys. We wanted to make sure we were bringing actual real-world project content for you. And I believe this was one of Tracy's projects. Is that right?
Yeah, right.
True. Yep. So
and
City of Westminster in Colorado.
So teaser, in 2 weeks, Tracy's going to be on the show, and we're going to talk about the site that's using this and some of the flow things that they're doing on his site that he's working on.
Yeah. Are you going to get into this one today, Dan, and why we call it the triple bypass?
We're going to be talking about bypass a little bit later on, but not really the triple bypass. Chris, can you speak real briefly to why they have 3 different bypasses here?
Well, because they've got demand for 3 different flow rates as the system's operating. So you'll get to it and explain a typical bypass, not a triple, but we'll get into it in a little bit more detail.
Okay, good. And then there's and then there's this we've got going on here. This is a nursery application, and this is a nutrient enriched water. So they're using a fertilizer injector, and then so they have a nutrient rich water source. So that just another more sophisticated version of a water source. So on these water sources, each water source has a different characteristic, right? So it could be availability, cost, the pressure, the water quality. All these things are going to influence the preferences on, do you want to use them separately? Which do you want to use first? Do you want to use them in combination? Those are all things that each water source is going to have different characteristics with. So we've got a couple examples to look at. So this first one has a pond and a pump as essentially it's a free water source. It's not in the left, and in the lower center, I've got a domestic water source. Now that pond has a smaller pump, so it can only pump out, run at 40 gallons a minute. So it makes it a little harder to run the system. They have the domestic can run 75 GPM, a little easier to get their watering done in their water window with that larger source, and they like the pressure better. So generally, they want to use the pond as a backup to the domestic water meter.
Secondary source.
There we go. Here's a wrinkle, though. Well, not really a wrinkle, but a consideration. That domestic meter, when they go over 100,000 gallons in 1 month, the water rate jumps up. It's tiered water rates. So they don't want to use this water meter all the time. When they hit 100,000 gallons, they want to stop and switch over to the secondary water source, the backup pond. Not particularly hard to do. So here's how they did that. So on the domestic water meter down in the bottom center, they call that water source 1, and they made it a priority 1. They set the capacity for this water source, and they determine this in the controller, and they set it at 75 GPM because that's how much it can flow. And then they set a water budget of 100,000 gallons for the month, and then click the box that says, when you hit this budget, shut it off. On the pond water source, they named that water source 2 and set it to priority 2. And they set the capacity at 40 GPM because that's what it can put out, but they didn't leave a water budget. So that's really all the configuration they needed to do.
Now, it's important to note, though, Dan, that with the priorities of the water sources, when programming the base station 3200 and assigning priorities to water sources, the way that it is engineered is that anything with a priority 2 will be treated as the same or equal. So if we've got 8 water sources and we have the ability to prioritize 1 through 8, everything is at 2, and then higher priority water source can be a priority 1, or if you've got more than 2 water sources, you can set the water source 1 as priority 1, water source 2 is priority 2, and water source 3 is priority 3. Or set water source 1 as priority 5 and have higher priorities below it. So just remember from Tech Talk Tuesday that when a water source is set at priority 2, they're all treated equally.
So the idea here is that the higher priority, we want to use that one first. So here's the way it might look in actual operation is the domestic meter is our highest priority. So it's going to pull from that and do all of our irrigation throughout the month running off of the domestic water meter. It makes their job easier. We set the capacity at 75 GPM so it can run up to 75 GPM worth of zones on the system. At some point in the month, though, depending upon which month it is, it's going to hit 100,000 gallons. They're going to essentially run out of water for that, and it's going to shut down that water source. It's taking it offline. Well, that's fine, but we have a secondary or backup water source. This is where the wonderful thing, it shuts off 1, and it's going to turn on water source 2 immediately, right? So now we're going to go to our backup water source. Well, This one is doesn't have as much capacity, but we've told the system that it only has a 40 GPM capacity. So it won't run any more than 40 GPM worth of zones. So maybe it might limp through with 2 zones at a time instead of running 3 to 5 zones at a time, right? So it's going to scale that back. And now there is no water budget on this. So it will run the second water source until the first water source, the higher priority, comes back online, like essentially the beginning of the month. Now, Andy, in across the country, is it always the case? Well, do people ever want to use the pond water first and the backup, the domestic as a backup? Do you see that?
Yeah, we actually see that quite often, particularly if either the pond or perhaps a well in this case the water could be free, right? Yeah. So in a lot of places they want to use the pond or the well unless the pond goes dry. Only then will they switch the domestic, which they have to pay for. So yes, in a lot of applications, it's the exact reverse of this setup.
Opposite of that, right? So different reasons for using one water source first. So if they're going to do the pond first, the trigger in which, or the condition in which to switch water sources would be what we call an empty condition. So when the pond drains down to a certain level, we're going to consider it empty or no longer use this water source. And we could do that with a soil moisture sensor, a pressure sensor, or any other
float switch, mechanical float switch. Yeah, it just needs some condition to tell it when it's empty to a certain level. And the same thing could be said about your domestic. The condition was gallons.
Right. So you could also, now if you didn't want to do that float switch thing, you could also, if it made sense for the site, you could do, when you've pulled 50,000 gallons out of the pond, switch water sources, right? So that you could set a budget on the pond. So several different ways to do this. It really depends on what your goals are, what you're trying to achieve. Okay, so this is complex, but it's still relatively simple. So here's one that's a little more sophisticated. And on this one, we've got 2 water sources. Water source 1 is a pump station that's capable of producing 40 gallons a minute. And water source 2 is another pump station that's capable of producing 65 gallons a minute. Now, both of these pump stations, there is no preference, right? They're equal. They're both new. They both work great. But pumps are designed to run a certain flow and a certain pressure. So what I don't want to have happen here is I don't want to have water source 2 running at and have the capacity of 65 GPM and only run 20 or 30 GPM worth of zones, right? That's going to be problematic for the pump. It's going to not be energy efficient. It's going to be cycling on and off, and it's just not good for the pump. So what I'd like to do is to run water source 1 when I have low flow, and then bring on water source 2 when I have higher flow. So here's the configuration on this one. We would go in the controller and set up the capacity for water source 1 at 40 GPM, set up the capacity for water source 2 at 65 GPM. And then in the controller, we're going to enable advanced dynamic flow allocation. So advanced dynamic flow allocation is going to use that smallest water source first, and then as the demand grows, it'll bring on that next water source. Here's what it looks like in real-time operation, right? We've got 35 GPM of demand out in the field from zones. So smallest water source comes online, right? We've got another spare 5 GPM, so we could maybe handle another small zone, maybe not. At some point, we're going to probably bring some more zones online. So now demand has grown to, 95 GPM. That overwhelms water source 1. Well, we're going to now add in our next water source, which is water source 2. So now I have 2 pumps running at the same time, meeting the demand. Now, when the demand out in the field drops, we start closing zones. Well, if it drops down down to 40 GPM, water source 2 will close. So water source 2 will be off and on only as needed. So.
Yep, and that's dynamic flow allocation, which is programmable in the controller itself.
Absolutely. Yeah.
This is amazing. Why is nobody talking about this, guys?
Because it's right in the controller, right? There's no additional anything to buy. You had to have the pump controls. I mean, it's really a pretty simple toggle off or on. Okay, here's a more sophisticated, an even more sophisticated one. So this configuration, I've got a single pump pulling from a lake, and this pump station is pretty big. This is capable of handling 120 gallons a minute. So it has to handle that 120 gallons a minute, we have a 3-inch master valve and a 3-inch flow sensor. Those are sized appropriately for 120 gallons a minute. Well, the challenge is some of these zones out in the far reaches, they're only running maybe 30 gallons a minute. Well, one of the things to consider on this one is a 3-inch flow sensor that's sized for 120 GPM. It has a hard time seeing 30 GPM. It's just not really sized for that one. So that there's a problem right there, or consideration, something we need to do about. A 3-inch master valve won't reliably close for 20, 30 gallons a minute. And if it does close, it's going to take a long time to close. So we've got flow sensor and master valve considerations. We need to do something better to do with this. So here's what we're going to do on installation out in the field. A couple of things we're going to do. We're going to leave that 3-inch master valve and 3-inch flow sensor in place, and we're going to name that control point 1. Then in parallel series, essentially bypass configuration, I'm going to install an 1.5-inch flow sensor and 1.5-inch master valve, and we'll name that control point 2. So the other piece of hardware we need here is a flow station, and we need our flow station to communicate or connect with our base station 3200.
Dan, why do we need the flow station to do this?
This is for the what we're calling control point grouping. We can't get that with the base station 3200 alone. This is an additional flow feature of the flow station.
Got it. So that configuration of grouping is not native in the 3200. It's powered by the flow station. So that computing power to do this and manage this is inside the flow station capabilities.
Correct. You're absolutely right.
Exactly.
I almost should have put that other triple bypass back in here, but I think one of the things that's really interesting about this is adding in that bypass is relatively easy, because it's right back at your water source, and it could be as simple as cutting in a T or saddling in a T for that control point.
Yeah, and from a secondary water source perspective, it's adding a second supply to a single water source. And being able to manage that and the performance of the system better.
Right. So water source isn't just necessarily the pump or the pond. It can be how we're controlling or supplying that. Yeah. Mm-hmm. So let's see what it looks like when we're running. So 30 GPM in demand of zones running out there. Well, this is going to go to the smallest water source first, because that's going to have the flow sensor and the master valve that we want. So 30 GPM in demand, the 1.5-inch master valve, 1.5-inch flow sensor are going to run. That's control point 2. It's been activated based purely on flow. This is not based off of programming of zones. Now that 1.5-inch can handle up to 35 GPM. So we're great here. But at some point we bring more zones on, and what's going to happen if demand jumps to 95 GPM, it's going to close control point 2 and open control point 1. Now that 3-inch flow sensor, 3-inch master valve can handle that additional flow, that additional demand, and run with this point. So this is allowing us, good flow resolution for our flow sensors, but also appropriate size master valve for our configuration.
Right. And running those two together would not add any value, because you can't get any more water than you have at your source. Right. So adding another 1.5-inch control point there, it's still coming from the same water source. And so there's no need to run them or have them open at the same time.
Correct.
Right.
So,
And then an additional advantage is if you are running through control point 2 and you have a mainline break, then you're limiting the amount of flow that you may be losing before we respond to that shutdown by flowing 1.5 inches worth of water rather than 3 inches worth of water.
mm-hmm. Now, Chris, isn't there a site? Have you seen sites that use one of them as normally open and one of them as normally closed?
Yes. So, but that's the beauty of the control point grouping capability, is having that or scenarios so that you can have both as normally closed, which makes baseline unique as well in the way that we manage that kind of bypass scenario.
Right. A site I was thinking about, so yeah, they could both be normally open or both be normally closed, I don't know if it makes sense to be normally open, or you could do either or. There was a site that used the 1.5 inches as normally open to always pressurize the main line and for leak detection, but would open up the larger 3-inch or 6-inch when demand grows. So they always had the main line was always pressurized with this smaller master valve and flow sensor. And if they had a mainline break, it would be a much quicker close than closing a 3-inch or a 6-inch master valve. Okay. Any other questions on this one?
Oh, we've got a number of questions.
Perfect.
That have come up. If you're done with your slides, we can address them, and we've got a few minutes to do so. So that's good. Cool. One of the questions early on was in regards to the domestic source and surface water source. Mm-hmm. How are we isolating potable from non-potable water supplies from contamination?
Right. You're still going to have to do that. You're going to be required by your code. You may have an air gap requirement. You may have a reduced pressure. You may have whatever your requirement is. Right. In many municipalities, you can't have those connections.
Right. And sometimes you'll have to use the domestic supply to refill the non-potable side and pump primarily from that. So
yeah, absolutely correct.
Good question. Depends on codes for sure. Mm-hmm. All right. Another one was asked by Antonia. Another question. Thank you. What happens when the water source 2, having a small water capacity, cannot complete the irrigation schedule to meet the water needs of plants within the water window?
Wow. That's what's awesome is that's like next level thinking, Tony. I love that.
And that's obviously coming from a regular attendee. And we address this in water windows. So from my perspective in answering this, we can handle that a couple of different ways. One, we can alter the water window or alter run times to accommodate for that. Because our limiting factors are going to be our water window and our design flow, correct? Mm-hmm. The other way we could handle it is by utilizing program priorities also, which takes us to a different level in how the controller responds to program priorities. And we may be able to justify a whole Tech Talk Tuesday just on program priorities. But for limitations and constraints that are put on us in that regard, we can prioritize programs to start and finish first, and then allow other programs that aren't as important or perhaps as high profile to stress or suffer. So a couple of different ways we can deal with that. Another question from Mr. Gela. If dynamic flow manager is running pump A and pump B, but pump A fails, will the manager recalculate demand to lower water requirements since supply has been reduced?
When a water source is offline, it's offline. And if we've told it that it has 65 GPM capacity and it comes offline, the capacity drops by 65 GPM. End of story.
Mm-hmm. And that's why we use a mainline flow setting as well as a water source flow setting, so that if your mainline, let's just keep the math simple, was set to 100 gallons a minute and you had 2 water sources, A and B, and each was 50, then you could run your full 100 capacity. If water source A goes offline and you're left with only 50, Now the controller knows it only has 50. Even though you put 100 for your main line, there's only 50 feeding it. So it knows what the source feeding the main line is capable of and will not exceed the limitations of either one water source or all the water sources.
Which kind of leads into the next question from an anonymous attendee, which could be our competitors wanting to know how our technology works. Does learn flow have to be performed at the zone level for this to work?
For which to work?
Anytime we're managing by flow, yes, we have to have learn flow at the zone level.
Right. So Chris, what happens if we have a zone that does not have a learn flow value? It has a 0. How does our system operate?
Would operate based on concurrency from an electrical capacity as set up in a controller. And
I think, correct me if I'm wrong, I think that if it has not learned the learn flow or it's a 0, it runs it by itself because it doesn't know if it's 100 gallon a minute zone or a 2 gallon a minute zone. Yep. It'll run it by itself because it doesn't have the info it needs to make any decision.
Correct. Yep. See where you're getting with that now. Perfect.
So,
excellent.
Yeah. Now, I think the other thing that would come up though is since it's getting the flow in real time, there's a flow variance and it's not quite enough to throw an alarm, it might have the capability of bringing other zones online, right? Because it's going to look for 20 GPM to fit in that hole, if you will. But if it's 18, that means it has another capacity of bringing in another 2 GPM.
That's a really good point, Dan, because when you think about specifically with this question and how it was asked, the word recalculate was used, and the controller is actually not technically calculating. It is running the flow in real time. So if there's an open 20 gallons a minute, it will look to fill that based on an algorithm that's in the controller that takes into account soak and cycle and a number of other factors, but it will look for the zones in real time and not run off of a pre-calculated zone run list.
That's right. Good point, Andy. We're not using math-based flow to create a run schedule. Right. We're using real-time data to respond to real-time occurrences that can affect the performance of the system.
Mm-hmm. Mm-hmm. Nice.
Excellent. Very good. A lot of interaction today. We've gone through the questions. We're almost out of time, believe it or not. So what do we have on tap for next week?
Well, I'm not
sayonara, Dan. We're kicking you out next week.
Yeah. Like so
it's
offline and
Andy and I.
Yeah.
Yeah, so Chris and I are going to be talking about green roofs, green walls, urban infrastructure, and there is a chance I will be on site at an application in New Jersey that has rooftop terraces and landscape. That should be a pretty unique site. If we can make the technology work, we'll be in field reporter style, coming at you live from a green roof or a green wall. So stay tuned for that.
Awesome.
Very nice.
Very good. Well, we appreciate everybody's participation again today. Always great to have you join us. We're always looking to provide good, useful information that you can take and apply in the field. So we'll be back next week. And again, you can rewatch this on the YouTube channel. What's that address again, Andy?
Baseline Web Training is the name of the YouTube channel. Baseline Web Training.
Awesome. Very good. We appreciate y'all. Go out and have a good week and be safe out there. And we'll see you on the next Tech Talk Tuesday.
Wonderful. Thanks, guys. See you next time.
See you then. All right. Bye now.